Okay, so at this point, we should have a good sense of how to work with a normal distribution. And so it kind of helps to have a conversation about, well, how do we actually know something is normal? And so there's a couple of different graphical ways to demonstrate that we're dealing with a normal probability. A lot of these we actually know about, so I'm going to spend more time talking about the last one, the normal probability or quantile plot. We know how to generate dot plots and box plots and histograms, and it turns out for the most part, those actually will be sufficient. But you also do need to be aware of what a normal probability plot does and how that actually works. So without further ado, let's get in. Okay, so what I'm going to do is I'm going to kind of work not quite backwards here, but I want to show you how these things are physically constructed. So to construct a normal probability plot, we're going to look at z-scores of 10 samples. So let me actually put these actually the normal the z-scores for data that actually is normal. So we have, if you look here, we have right about the center here, we've got negative 0.123 and positive 0.123. So these are all negative 0.376, positive 0.376. These things are z-scores, and they are symmetrical about 0. And so we're going to compare them with some raw data. And essentially what we're going to do is we're going to partner these things up and create a graph, a scatter plot, and just kind of look at what happens. So let's go ahead and take out our calculators. Okay, so when we go to our calculator, we're going to go to our stat edit. We're going to go to our lists. And let's go ahead and type in the observations. So we're going to type in the 3.21, the 2.49. We're going to type those numbers into list 1 because that's what we want to know is normal or not. Those are our observations. So let me get all that data typed in. And I don't necessarily think you want to watch me do this, so let me pause the video and get all these numbers typed in. So take a second and type in the observations in list 1 and the z-scores in list 2. Okay, so now that we have all of the data typed in, we're going to rearrange these guys. So my list 2 are these z-scores, and I actually typed them in order. And if you didn't, then that's okay. I'm going to show you how to rearrange it. We actually did this a while ago. What my goal is I would like to have the very smallest number in my data set partner up with the negative 1.39. I want the next smallest to partner up with the negative 1.001. And so on and so forth. So I want the smallest number to partner up with the smallest, and I want the largest number to partner up with the largest. Okay. Okay, so to sort our data, we're going to go to the list menu. So hit second list, and I'm going to arrow over to ops, and it's going to say sort A or sort ascending or sort descending. And I want to sort ascending. So I'm going to tell the calculator, and I don't know why I've got this extra thing in here. Let me clear that out again. Let me try that again. I'm going to tell the calculator to sort list 1 because that's what I want to rearrange. And if you need to sort list 2, you can go back in and just tell it to sort list 2. And so at this point, when I go to my lists, they're rearranged in order, and I've got the smallest number with the smallest number. Okay. Then what we're going to do is we're going to create a scatter plot of these two sets of numbers. So let me go to stat plot, and right now my plot is turned off, so I'm going to go turn that on. Just arrow over to on, and I'm going to arrow down to type, which is the scatter plot type, and I want list 1 in the X list and list 2 in the Y list. So let me change that, and that all looks great. So we want zoom standard, sorry, zoom stat, so 9 zoom stat, and I get that nice pretty picture. Okay, and so what am I looking for here? Well, in order to use a normal probability plot, I'm looking for a straight line type graph, and that looks pretty straight line to me, which means the lower observations are just as far from the mean as the upper observations are. And so because it looks like a straight line, then I can say that the data behaves normally. Okay, now the interesting thing is the calculator actually has this particular thing built in. So let me kind of go back to what I did. You're never going to do this again. I gave you 10 numbers that were normally distributed. That was list 2. And we compared them to the raw data, which was list 1. It turns out, let me go back to stat plot here. Okay, so in going back to stat plot, we actually have this nice feature already built in. We just didn't know it existed. If you arrow down for type and you go all the way to the end, it's right after box plot, we get this, it sort of looks like a scatter plot, but it looks like a straight line. That's what's called a normal probability function. So if I hit enter, it's going to say, it's going to change what it asks me. It's going to say, hey, where's your data at? Now, the raw data happens to be in list 1. And then it's going to want to know, well, how do you want me to set this up in terms of the X or Y? We'll just leave it as X as default. And then we're going to hit, go back to our zoom, and then 9 again. And we should notice the exact same picture. That's actually what that normal probability plot does, is it finds the z-scores that are relevant based on sample size. It partners them up for us and then draws the picture. So in other words, we don't have to do that process by hand again. We can just, given our raw data, we can calculate a normal probability plot, which basically opens up for all the other graphs as well. Okay. So what does a normal probability plot do? It takes an observation and plots it against a comparable z-score. And what we are looking for is whether or not the quantile plot forms a straight line, and if it does, then we say normally distributed. If it doesn't look like a straight line, then we suggest that it's non-normal data, and any points that are far away from the line sort of imply that they are outlier data. And then neat little word that we don't do too much with, but I'll introduce it to you here. If we happen to have points that are on top of each other, we call that a granularity. These are repeated observations of the same number within a given data set. So that said, let's take one more look at this. So we're going to type in these numbers and go through the hoops and make sure that we're going to confirm whether or not they're normally distributed or not. So going back to our calculator, go back to stat list, and this time just go over to list 1. So I'm going to delete out all these other data that I got in here. We're just going to type in the data into list 1, and we're going to check a couple of different ways to see if it's normal and just kind of compare and contrast the different methods. So I don't think you necessarily, again, want to watch me type in the numbers. So let me pause this and I'll join you in a second. Okay, so with all of our data typed in, we're going to go back to stat plot, and we're going to go, we'll just kind of review the different methods of graphing, because remember, there's several different graphical methods that will work. I'm already set up for a normal probability plot, so I'm just going to do that one. So let me go back to zoom stat here, and there we go. Notice I've got several observations that are on top of each other, so they're a great example of a granularity, repeated observations of the same number. Let's compare that with, so let me go back to stat plot, and let's do a box plot. So arrow over that option, the one that has the dots on it, remember, will indicate whether there's an outlier. Let's see. I want to change my list to say 1. I don't have if I'd had a list of numbers that talked about how often these numbers showed up, I didn't go through and sort the data that way. So a frequency should just be 1 for this example. And then if I hit enter, try to hit enter. Oh, I'm sorry. We want stat plot again. So number 9, there's my box plot, and box plot looks fairly symmetrical. So again, the normal probability plot suggested it was normal. The box plot suggests that it's normal. So now I just need to do the histogram. That's always good practice. So go back to here and pick that choice as far as our graph goes. List 1 is where the data is. Frequency is 1. We're going to go zoom stat, and then I'm going to go back and modify the numbers. Actually, I don't really think I need to modify. Let me double check on the window here, but let's see. It goes from 45 to 59, and it's counting by 2s, which sounds about right. We want about 10 rectangles in a given histogram, so our graph looked pretty good actually, so I didn't really see much to adjust there. And even looking at the graph has a large hump of data in the middle. Almost looks fairly uniform there, but on the lower amounts on the end, it's there. Given our different graphs, whether it's histogram, box plot, or normal probability plot, all 3 of them indicate normality. So this particular data set we are now safe in saying is normal. So let me kind of sum that up then. Before you get to use the word normal to describe data, you need to have confirmed it using some sort of graphical method. Now, if the problem does say it's normally distributed, then you just need to say that. I was told it was normal, and I didn't have to confirm it. But you do need to do something before you get to call a particular data set normal.